So example 6 here we have how much interest is earned in 6 years on $8,000 deposited on an account paying simple interest compounded monthly. Again, now I know it's a compound problem, so I'm going to be using a compound interest formula, but I do want to make sure I understand what they want. They want the interest I, not the future value of the loan or of the investment, so you got to be really careful with this. Again, to find I, we need to know the future amount and subtract off the present amount from that. So we do know the present amount. Let's go through the problem and identify what we know, I guess. Earned in 6 years, so that's going to be my time there, 6 years. $8,000 is the original amount deposited, so that's my P value right there. 9% is my interest, so that's giving me my R value of 0.09, compounded monthly, so that gives me my N value of 12. Again, I do know P, but I don't know A. So to find the interest, the first thing I need to do is find A. I'll use the compound interest formula. A equals P times 1 plus R over N to the NT. I've identified my variables, I've identified my formulas, so now I just plug it in and use my calculator. So let's go ahead and plug in the values for this first one here. Seems to me like I would have A equals 8,000 times 1 plus R, which was 0.09, divided by N, which is 12, raised to the 12 times T, which was 6. So how much money would I have in this account after that time? Well, I'm getting, put that into your calculator, and please do it yourself. 8,000 times, I'm getting $13,700.42. That seems like a realistic number. It's more than $8,000. It is 6 years. That is a pretty good interest rate, so that does seem like a good amount of money right there. So the question then becomes not how much is in my account, but how much did I earn in interest? Well, to determine interest, I take that future amount, which was the $13,700.42. I subtract off that original amount, which was $8,000. That tells me that the interest that I earned in this was, well, put it in your calculator, I'm getting $5,700.42. That's how much interest I earned on the account. Again, be very careful. The question does not ask for the A amount, it asks for the P amount. All right, so what's the rest of this page about? I encourage you to read it and understand what's going on, but let me kind of talk about this. We are still going to be using the compound interest formula. Nothing's changing. We're using the compound interest formula, but we're going to ask the question a little bit differently. Instead of, what if I put $8,000 in an account now, how much would I have in 6 years? I'm going to reverse the question and change the order. So for instance, maybe I'm in college and I want to buy a car when I get out of college. Maybe I want to have $15,000 to buy a car when I get out of college in 4 years. So the question becomes, how much do I need to put into an account today to ensure that I have that $15,000 in my account in 4 years when I graduate? So when I say that $15,000, that's not the amount that goes in the account. That's not P. That's actually the future value, A. So I'm giving you A, and I'm asking for you to solve for P. So what we do is we take that simple interest formula that we looked at before, A equals P times 1 plus R over N to the NT, and instead of it being solved for A, we actually want to solve it for P. So since it's multiplication, the opposite operation of multiplication is division. We're going to divide both sides of the equation by 1 plus R over N, all raised to the NT. And we have our our compound interest formula solved for P, the present value, rather than solved for A, the future value. Again, this is one of the formulas that I'd write down, put on a note card, because I'm going to use this anytime that I want to solve for P. So all the variables are the same. The formula is truly the same. It's just solved for a different letter.